Hello everyone, welcome to AriserTalent. I'm your maths faculty Arpita. Students, we are discussing linear equation in two variables, and so far we have gone through different categories of methods of solving these equation in two variables, and then we studied this cross multiplication method. Now cross multiplication method we have solved this complete, right? After that we just solve this example of by cross multiplication method. This is about the constant 2, 6, 10, 3, 7, 13. These are all numbers. This is about numbers. So in the next category or variety of question, that is that we are going to solve this kind of complex situation. In that we are not having numbers, but we are having this algebraic constant, right? Okay. So how will you solve these kind of question? Now student, understand this, the procedure is same. Okay, what you have to do, just follow the steps, just follow the procedure and you will get the answer. How? Let's have a look. This is the question, solve the following system of equation by cross multiplication method, and the equation is, students, ax plus by equals to 1 first. This is the first equation, and the second one is bx plus ay equals to a plus b whole square upon a square plus b square, then minus 1. So we are going to solve this. For solving such kind of particular equation, what we have to take care of is we should convert it in a basic equation a1x plus b1y plus c1 equals to 0 and a2x plus, that is plus b2y plus c2 equals to 0. This is our basic or standard form of the equation, right, in two variables. Okay, so now we are going to solve it. So here the solution. We'll first write these equation in terms of standard form. We have to do little less in that, we just can transpose it, but we have to solve this. So I am writing this first. Okay, so this is bx plus ay equals to a plus b whole square upon a square plus b square minus 1. Okay. Now, what we'll do, we'll take the LCM here, right there, okay, and we'll open this. A plus b whole square is equals to what? A square plus b square plus 2ab, right? Okay. Now, bx plus ay will become what? This as your LCM, a square plus b square. Then here a square plus b square plus 2ab. Now, minus 1 will give you minus of a square plus b square, that will become minus a square minus b square. So just write there, minus a square minus b square. Now can I cut this a square plus b square by this minus a square and minus b square? Just cut that crap. Okay, then bx plus ay equals to what, students? That is equals to 2ab upon a square plus b square. Right, now this is our equation second. What we are having as equation 1 is, which is given, this ax plus by equals to 1. Ax plus by equals to 1. So this can be transposed in the equation ax plus bx plus ay minus 2ab a square plus b square equals to 0, right? This is equation 1. Now the second given equation is ax plus by equals to 1. Now equals to 1, now the 1 will transport to this side, that will become minus 1 equals to 0, right? Or just I can write it there. Now what will I do? I have to solve it by cross multiplication method. Applying cross multiplication method here. When we'll apply the cross multiplication method, what will we do? We'll just simply write x here and y here and 1 here. Okay, now that's minus. This is the format. Now what we have to do? We just have to pick whatever we are choosing x, then hide this one and write these two terms. Okay, then cross multiply. Okay, so talking about this x, I am having here a, here b, here minus of 2ab upon a square plus b square. This side I am having minus 1. Right or wrong? Right? Now I'll be having this y minus y. So I'll hide this y, and what I'm remaining with, this b and a here, this b and a here, and this minus 2ab upon a square plus b square here, minus 2ab upon a square plus b square here, and 1 here. Right? This minus 1 here, minus 1 here. Now for 1, I'll hide the constant terms here. I'll be remaining with the constants of x and y's. So that will be b and a, right? B and a. And here it will be a and b, a and b. Now what is cross multiplication? Just simply this. Okay. Okay, so can I just rub this portion? Okay, so now I'll be writing this side. Okay, come this side, students, so that we can move forward. Okay. Now that x, y and 1. So 1, y and x. So if I am talking about x here, that will be minus of a. A multiply of minus 1 will give you what? Minus of a. Right? Okay. So, okay. Yes, minus of a. Now, here I'll be having always a minus. Okay, so minus. Now this b multiply of minus this. What will it become? B multiply minus 2ab upon a square plus b square, simply minus of a 2ab square upon a square plus b square. So can I write this? Now minus and minus will become plus. So I am here writing a plus. Here I am having this plus, then 2ab square upon a square plus b square. Okay, when I will talk about this y minus 1 multiply by b will give you minus of b. So minus of b. Now minus of minus. Now this multiply this to this. Now a multiply by minus 2ab. First minus here. So it will give a minus term, negative term. Negative and negative is positive. So I am writing positive here. And a multiply by 2ab. So what will be the square? A will be the square. 2a square b. 2a square b upon a square plus b square simply. Now I am writing about this. Now that will be b square. Okay, b square minus. Minus should be there. Okay, now a square, right? So a square here. Okay, I followed the procedure. Now I can just solve it. So that will be equal to, here it is x, here it is y, and here it is 1. Right. Now if I will take the LCM here, okay, then I will be writing just a square plus b square here. If a square plus b square here, then this minus a will be multiplied by this. So, a multiplied by a square minus a cube minus a multiplied by b square minus of a b square. Then here, this is the same the LCM. Okay, so that will be plus of 2ab square. This is about x. Okay, now about y. Okay, we are not considering this minus sign here, right? So, minus y will be, again the procedure will be a square multiply by b, a square b, but of minus, right? So, minus b a square plus minus b multiply by b square. So, minus b cube minus b cube plus 2a square b. So, again 2a square b, then divided by a square plus of b square. Now, this is again a square minus b square. Understood? Okay. Now, come this side. This is a cube. Okay. This is ab square of minus. This is ab square of plus. So, these term will be added. Right. Here again minus minus ba square. Again here 2ba square. So, these term will be added, or in this case subtracted, because there is a minus signs here. Okay. So, that will become again x equals to this minus y equals to 1. Right. This one is simply b square minus a square. So, we don't have to do anything with that particular thing. Now, come this side, that will become minus of a cube, then minus and plus. So, plus is greater, so that will be plus ab square, Now, that will be transposed to this side. So, can we just write a square plus b square here? Okay. Like this only, that will be a square plus b square here. Okay, and that will be reduced to minus of b cube, right? B cube plus of a square b. Okay, clear? Now, note this, student, because I am going to rub this part, right? Okay. Now, student, from this come there. Now, we are having this x of a square plus b square upon minus a cube plus ab square, that side, equals to y, not minus y, of a square plus b square upon minus b cube plus of a square b equals to 1 upon b square minus a square. Right. Now, what can I do? I can just simply take a common here and b common here. Okay. So, that will give me, right, minus of a, can I take this common? Okay. So, that will give me a square minus of b square, isn't it? Okay. Then, or simply I won't be taking common this. I am just simply will take common a. Okay. So, that will be a square minus b square. Right. Now, here that will be minus of y, a square plus b square upon. I will take common what? I can take common what? B. Right. So, b here, then minus of b square, here that will be minus, right. Okay, that will be minus of a square and plus of b square. Here also that will be minus of b square and plus of a square. Now that is equals to 1 upon b square minus a square. Now b square minus a square here and b square minus a square here. Now if I will take this minus common here, this side, if I will take this minus common, so what will it become? Minus sign here, then that will be plus and that will be minus simply. Why I am doing this? Because b square minus a square in multiplication, also b square minus a square in multiplication, simply cut this term. This is the reason. Now, this implies that x a square plus b square equals to what? 1, right? So that will be 1 here. And y, that is minus and minus, so minus and minus will cut. So what will it become? Y a square plus b square upon b, right, equals to 1. If I am taking these two proportion, I will be getting this, and if I am taking these two proportion, I will be getting this. So from here, is it clear to see that we could have the value of x equals to a will transpose here a square plus b square, right, and y equals to this will transpose here, so b, and that will come here, so a square plus b square. So students, now this and this is something you are looking for, right? Because your question in this question you will be solving this for by cross multiplication method. Okay, so you have to got the answer. Now your answer is for x it is a upon a square plus b square, and for y it will be b upon a square plus b square. Clear? Okay, so have a look on that and just note it. We'll move forward after this. Noted? Okay. So now you have covered both kind of questions, right? Numerical one and the algebraic one, right students? So it's easy to understood. Okay. Now I have taught you about this, but we are just repeating it. Why? Because we are going to have some questions on it. So just take, exercise with your mind whether you know this or not. If you are not knowing this, go to the theory section and watch it again to make a proper conception of that. Right. System of equation, normal equation we are having here is a1x plus b1y plus c1 equals to 0 and a2x plus b2y plus c2 equals to 0. These are two equations. Now, when that will be unique solution, there will be unique solution. There will be a unique solution if a1 by a2 is not equals to b1 by b2. If a1 by a2 is not equals to b1 by b2, then that is consistent with unique solution. Right? We have learned that, but we are just revising. Okay? Now it shows that line represented by equation 1 and 2 are not parallel, they intersect. Right. B. A1 by A2, B1 by B2 and C1 by C2 are all same. What does that mean? That means that these lines are coinciding, overlapping each other. It shows that these lines represented by equation 1 and 2 are coincident. Right. It is inconsistent if A1 by A2 is equals to B1 by B2, but they are not equals to C1 by C2. Then these lines are parallel and non-coincident. Now, this is parallel. Okay, but these are overlapping and these are not overlapping. Okay, so we are having basically these three. Now, for this first point, we were having graph like this. in which we were having two lines, right? Two lines. Let's suppose this is line 1 and this is line 2, and this is x and this is x dash, this is y dash and this is y. In that condition, these two lines are intersecting. That means here in this condition, a1 by a2 is not equals to b1 by 2, not equals to, right? Okay. Again, the second one. In that, I am having this graph x, x dash, y, y dash, and I am having two lines, this line and this line, right? L1 and L2. In this condition, students, we understood that A1 by A2 is equals to B1 by B2 but not equals to C1 by C2. A1 by A2 equals to B1 by B2 but that is not equals to C1 by C2. Parallel lines? Okay. Now the third category. Now the third category is, I am having the same graph, I am having some line L1 and some line L2, right. Now, for first line, I am having this line plotted on graph, right. For the second line, I will be having this line. So, this is L2 and this is L1. So, in this case, student particularly, I will be having my A1 by A2 equals to B1 by B2 equals to C1 by C2 in this particular graph. Okay. So, should I remove? And we should move to the questions. We will be having some important and funny and interesting questions on that. Okay. Why funny? Why funny? It's just, I just said that. Okay. So, here the question, show that the following system of equations has unique solution. How to show? How to show equation is having unique solution or inconsistent or consistent? How will you show that? You'll just simply go with the coefficients and you'll find out the ratios of their coefficients, right? Like A1 by A2, and we'll compare it to B1 by B2, and if you find similarity between these two, you'll go to the C1 by C2 and check whether they are equal or unequal or what is the process, right? So, it's saying us, so show that the following system in the equation has unique solution. Now, the equation we need to write here first. Given equations, given equations, what are the given equations? These are 2x minus 3y equals to 6. This is the first equation. Now, the second equation is x plus y equals to 1. This is the second equation. First equation is 2x minus 3y equals to 6 and the second one is x plus y equals to 1. Okay. Now, what we know that we should have the proper system, proper arrangement of a1x plus b2y plus a1x plus b1y plus c1 equals to 0 and a2x plus b2y plus c2 equals to 0. So, that implies that these reactions can be written as, these are not reactions, these equations, okay. These equations can be written as like this, okay, this first, and if we compare this, comparing this equation, let's suppose this is the third equation and fourth equation. to standard form. And what are these standard form? A1x plus B2y, B2, that's not B2, B1y plus C1 equals to 0. Okay, that is equal, that again second equation is that the equation? Is that the equation? Is that? Okay, so we are having this equation. So, if we comparing these two equations with these two standard equation, what will got? Implies that A1 equals to A2 equals to B1 equals to B2 equals to C1 equals to C2 equals to. Now student, I know you are very good at comparing things, right? So you just can compare it. Now A1 here 2, A2 here 1, B1 here coefficient of y minus 3, here B2 coefficient of y 1, here coefficient, the constant term minus 6, the constant term here minus 1. Alright. So now what are you looking for? Come here, and what you have, A1 by A2 equals to B1 by B2 equals to C1 by C2. Alright. In this case, not equal. Right. So if we go for A1 by A2, B1 by B2 and C1 by C2, that shows the characteristics of these two lines, that they will intersect, or they are parallel or they are not parallel, right? So what will I have here? 2 by 1, here I am having minus 3 by 1, and here I am having minus 6 by 1. So this question is asking us that whether the following equation or system of equation is having unique solution. Now go back to the unique solution. When a system is having a unique solution, only at that time when these two proportions are not equal. Just don't care about this third proportion. This will come into existence only if these two are equal. But if these two are not equal, and here we can say this, yes, this 2 is not equals to 1 by 3. Now A1 by A2 is not equals to B1 by B2, as the ratio A1, A2 and B1, B2 are not equal. What does that mean? This implies that system is they are intersecting each other, or we can have the unique or the solution. System is having unique solution. System is having what? Unique solution. Okay, so note this, and we are going to do much more questions of this category. Okay, so understood that thing. Now we are having much more questions based on the same pattern. Likewise, this was the very basic example. You just have to put the values and find out whether this A1 by A2 is equal to B1 by B2 or not. Right? It's just so basic. Now what can you have? You can have some you are having these terms 2, minus 3, 6, right? 1, 1 and 1 here as the constant part of this term, the coefficient. Okay, now what will you have? You'll be having some algebraic things here. You can have this like k minus 1 x plus k minus 2, let's suppose y equals to 27, and you are provided with equation similar to this equation, and then you ask that if this is unique, this is having unique solution, or this is having infinite many solution, then what is the value of k? Then you'll using these that whether in this particular, if you are given with the unique solution or if you are given with the infinite many solution, then which thing will be having? Okay, if it's having no solution, then what? So you'll be having this kind of question where you have to find this value. That can be k here, that can be a or b here, that can have both, like that can have a minus b multiplied by x plus a plus 3b equals to multiplied by y equals to 28. Something like that can be happen also. So we will understand this kind of questions also. We'll do that for surely. Okay, but in our next lecture, this session it's enough. Okay, so study and we'll meet again. Thank you. Bye.